In today's class, we're going to talk about the basic concept of physics, such as displacement, distance, velocity, acceleration, projectile motion, force, momentum, and others. The first term we're going to discuss in this class is distance and displacement. Distance talks about how far an object is traveling. You understand? Distance refers to the total length traveled by an object. That is what is meant by distance. So let's assume that we have city A, we have a city called A. Then the distance between city A and city B is 100 kilometers. And the distance between city B and another city C is also 100 kilometers. If we are told to calculate the total distance traveled, we are going to add the distance between A and B and the distance between B and C. That is what distance talk about. The distance is the total length traveled by an object. Do you understand? So the total distance here is what? 100 kilometer. Oh, this is 100. 100 kilometer plus 100 kilometer. This is equals to what? 200 kilometer. Do you understand? So the distance tells us the total length travels by an object. Do you understand? The distance is how far the object is traveling. Now let us look at the other part of it, which is displacement. Displacement is the shortest distance traveled by an object. Are you getting it? Displacement is somehow similar to distance, but displacement talks about the shortest distance. Now let's look at this example. Let's say a boy traveled 8 meters east and then turned and traveled 5 meters west. Calculate the distance and the displacement. Don't forget that distance is the total length traveled by the object. So let us represent this on a number line. The boy starts. Okay, this is the 4 cardinal points. We have 4 cardinal points. This is north, south, west, east. From the question, the boy traveled 8 meters east. You understand? So he traveled 8 meters east. You understand? This is the starting point of the boy. So he traveled 8 meters east and then turned back and traveled 5 meters west. So from this point, he turned back and traveled 5 meters west. So this is 5 meters and this is what? 8 meters. Do you understand? Now we are told to calculate the total distance of the boy. The total distance refers to the total length traveled by an object. Are you getting it? So the total length is what? Distance. Distance is 8 meters plus 5 meters. Do you understand? So this is what? 13 meters. Now, how do we determine the displacement of this boy? The displacement cannot be 13 because the displacement tells us the shortest distance traveled by the object. The displacement is the displacement can be calculated using this formula. Displacement is equals to the final position minus the initial position. Do you understand? That is the final position of the boy minus the initial position. Now, in order to calculate the displacement is here. This distance, the distance between here and here, that is the displacement of the boy. You understand? So now, in order to calculate the displacement, that will be what? 8 meters minus 5 meters. That is what? 3 meters. Do you understand? So the displacement is calculated as F, the final position of the boy, which is here, 3 meters, minus the initial position of the boy, that is 0. So 3 minus 0 is equals to what? 3. You understand? And you can do it otherwise. Just subtract 8 from 5 meters from 8 meters. You are going to get the displacement of the boy. Do you understand? So the displacement tells us the shortest distance traveled by the object. Do you understand? So now it is important to note that displacement is different from distance. Distance is a scalar quantity, while displacement is a vector quantity. A scalar quantity is a quantity that has only magnitude but no direction. For example, if I said that a boy traveled 5 meters, that 5 meters, I don't know. You don't we are on the that's from that statement, we are not given the direction to which the boy traveled. Are you getting what I'm saying? The direction in which the boy traveled is not given. So therefore, that is a scalar quantity. That is what distance. But for adventure, we are given a boy traveled 8 kilometers to the west. Now we are given the direction. Therefore, that is what displacement. So displacement has both magnitude and direction. The magnitude tells us the length which an object travels. I get what I'm saying. So both scalar and vector quantities has magnitude, but the difference between scalar and vector quantity is that one has direction and the other does not have direction. Scalar quantity does not have direction, while vector quantity has direction. So distance is a scalar quantity. You understand? Distance is a scalar quantity. Why displacement is a what? Vector quantity. You understand? And I've already given you example. Now I want you to try this. Is this a scalar quantity or vector quantity? Is this displacement or distance? When we say that a boy walked 70 miles, is that distance or displacement? Now, just write your answer down. The answer is that, now look at that statement. The boy walked 70 miles. This means that we didn't know the direction in which the boy was traveling. Are you getting it? We are only told that he covers a particular distance. Therefore, that is distance, because we are not given the direction. But in the case of displacement, we must be given the direction. Now, I want you to try this. Determine whether this is a distance or displacement. A motorist traveled 50 kilometers to the east. Is that displacement or distance? Yeah, that is displacement, because we are given the direction to which the motorist traveled. Are you getting it? So when you are given the magnitude to which an object traveled, and you are given the direction, that means that we are talking about what? Displacement. You understand? When we are given the magnitude which an object travels and the direction to which it traveled, that means we are talking about displacement. Now, when we are given only the magnitude, that means that we are talking about the distance. Do you understand? Now, when we have distance plus direction, that is displacement. Are you getting it? When we are given distance, 5 meters, maybe 8 kilometers, 5 meters to the east, not south, west, east. So 5 meters to the east. So this is what? Displacement. You understand? Now, so that is the basic idea of distance and displacement. Now, I want you to attempt this question. If a boy walk 30 meters eastward and then walk 40 meters northward, what is the displacement of the boy? And calculate the distance of the boy. We are told to calculate the distance and the displacement. Now, let us represent this in a diagram. These are 4 cardinal points. You understand? We have north, south, west, east. You understand? Now, back to the question. The first part of the trip of the boy was that the boy walked 30 meters eastward. You understand? Let's say this is the starting point of the boy. So he walked 30 meters eastward. Let's say this is 30 meters. And then he covers another distance 40 meters northward. You understand? Another distance 40 meters northward. What is the distance and the displacement? Now, don't forget that I told you distance is the total length traveled by the object. Are you getting it? So the distance here, the distance is equals to the 40 meter plus 30 meter. You understand? The distance is 70 meter. Now, what of the displacement? The displacement is the shortest distance traveled by the object. In this case, the shortest distance traveled by the boy is the displacement of the boy. So the displacement here will be here. This will be the displacement. Displacement. You understand? So now, from your basic trigonometry, if we have a right angle, triangle, you can see that this has formed a right angle triangle. Now, if you have something like this in basic trigonometry, in order to calculate the length side, the longest side of this triangle, what are we going to use? Yeah, we are going to make use of Pythagoras theorem. The Pythagoras theorem states that the square of the longest side, which is the hypotenuse, the square of the longest side is equals to the sum of the square of the other two sides. I get what I'm saying? The square of the longest side, don't forget that the longest side is the displacement of the ball. Are you getting it? So the square of the longest side is equals to the square of the sum of the other two sides. So this is first side and this is another side. So that will be hypotenuse square is equals to what? Opposite squared plus adjacent squared. You understand? So the hypotenuse is what? This the displacement. We represent it as what? X. The hypotenuse is the displacement of the ball. So I'm going to represent it as x. So x is equals to opposite square. Opposite is what? Opposite is the angles. The side that faces the angles. That is what? 40. So I'm going to have 40 squared plus the adjacent is what? 30. So plus 30 squared. So x squared, which is the displacement, is equals to 40 squared. 40 squared is 1600 plus 30 squared is 900. You understand? So x squared is equals to 1600 plus 900. That is 2500. So in order to get the displacement, we have the square root of both sides. So I'm going to have square root of this and square root of this. This square will cancel this square. So I'm left with x. The square root of 2500 is 50. So the answer, the displacement is what? 50 meter. You understand? So the displacement tells us the shortest distance traveled by the object, and the distance tells us the total length traveled by the object. Do you understand? So the displacement is 50 meter. Do you understand? So I want you to take note of that. And don't forget that I told you that displacement is a vector quantity, and while distance is a scalar quantity. Now let us proceed to another concept known as the speed.